John is selling yearbooks for his school. Each book costs $20. How much money will he earn? We're missing a really important piece of information here. How many books have been sold? If we don't know that information, we can turn the problem into a simple equation. The total amount of money earned is going to be equal to 20 multiplied by the number of books. We can take that formula and create a chart of the possible results, choosing whatever numbers of books we want. So if John sells 10 books, we replace the word books in our formula with the number 10. And that's going to give us how much money he would earn from selling 10 books, $200. If instead we decide to calculate how much money he would make from selling 15 books, we just replace the word books with the number 15 and then do the multiplication. That would earn him $300. If he sold 20 books, of course, that gives us $400. We could have picked any number we wanted for the books sold. 1, 2, 5, a billion, it doesn't matter. The formula is going to remain the same. This is a very simple form of a linear equation, and we can turn it into a more direct mathematical form by replacing the orange total amount of money earned with a y and the green number of books sold with an x. We're also going to simplify the number 20 down to just 2. But it works the same way as the previous slide. We can create a chart that will tell us the various results that we will get depending on what x we choose to put into the problem. In this case, I've decided to use 1, 0, and -2, but we literally could have used any value. Once we've chosen our values for x, we need to then put them into our equation. We replace the letter x, for example, with the number 1 and see what it spits out. 2 times 1 is, of course, going to be 2, so we write a 2 underneath the 1 in the y row. If we put a 0 into the problem, 2 times 0 is 0, and so the result is 0. And if we put a -2 into the problem, 2 times -2 is -4, and now we have 3 different results for putting 1, 0, or -2 into the equation. The reason this is called a linear equation, and the reason that we're using x and y, is because of a unique property of this type of formula. We've been using the letters x and y for a little while now to create coordinate pairs. And if we take our x input and the y output that it creates and turn them into a coordinate pair like this, we can then draw that dot on a Cartesian graph. We can continue to do so for the 2 other entries. We put in a 0 and got out a 0, so that turns into the point 0, 0, which is origin, right in the middle. And when we put in a -2, it spat out a -4. We can pair those up as -2, -4, and put that on the grid as well. The reason this is called a linear equation is because any input-output pair that you create will fall on a perfectly straight line. If you have a point that doesn't lie on that line, you haven't done your math correctly. These formulas, these type of equations, have to create a straight line. It's a mathematical law. Let's look at another example. What if instead we use -2? And this time we choose our x values as -1, +1, and +2. Let's see what happens when we replace the letter x with each of those 3 values. If we replace the x with -1, we get y equals -2 multiplied by -1, which is +2. So if we put a -1 into this equation machine, the output is a +2. If we put a +1 in, it spits out -2. And if we put a +2 into the machine, the result is a -4. Once again, we can turn these pairs into coordinate pairs. So -1 creating +2 can then turn into the pair -1, +2, which we can graph. 1, -2 becomes 1, -2. And of course, the final set becomes 2, -4. Once again, those 3 points lie on a perfectly straight line, hence a linear equation. If our multiplier is 3 and we choose to use -2, 1, and 2, well, -2 times 3 gives us -6. 3 multiplied by +1 gives us 3. And 3 multiplied by +2 gives us +6. Once again, turn these into pairs and graph them on the grid. And you end up with a perfectly straight line. Last example. What if instead of multiplying by a whole number, we multiplied by 0.5 or half? Same thing should occur. If we put -2 into this formula, half of -2 is -1. +2 goes into the formula, half of +2 is +1. And if we put in 4, half of 4 is 2. We can then turn those pairs into coordinates on the graph. -2, -1, 2, 1, and 4, 2, which create a straight line. In your OneNote homework folder, there is a brief worksheet titled 12th of October, Intro to Linear Equations. That is due before our class tomorrow morning. I hope you have a great rest of your day.